So far in the LARP, you've received data from the Bitcoin Core download and from me, the facilitator. In the real world, nodes establish communication channels between each other directly. They use these communication channels to send and receive block and transaction data. In this phase of the LARP, we're going to create connections between nodes and introduce our first network messages, I have transaction and send transactions. This is also the first phase where we have a goal. In fact, we have two goals. The first goal is to see how many other nodes mempools you can get the transaction you wrote in the last phase into. The second goal will be to get as many of the other nodes' transactions into your own mempool. Remember that every transaction that goes into your mempool must be valid. In this phase of the LARP, we'll be using two of the network cards that you have. I have transactions and send transactions. Bitcoin is a peer-to-peer network, which means we need connections between nodes. In this phase, we'll connect nodes and get them to send and receive transaction data between each other. They'll be making copies of transactions and using the transaction validation checklist that we learned how to use in the last phase to check all the new transactions that they get from peers. To get nodes connected, you have a roll of string and a pair of scissors. With the string, physically connect each of the tables to another table. You may want someone to help you run the string between tables. Each table will want someone to manage the strings coming into their node. Make sure that each node has connections to at least two other nodes. At most, I'd suggest no more than 3 connections for any one node. Have fun stringing them together. In the last phase, we just added a new transaction to our mempool. Every time a new transaction lands in your mempool, you need to tell every node that you're connected to about it. To tell your peers about what transactions you have, you'll need to communicate with them over the network with network messages. You have 4 different types of network messages that you can send. To tell our peers about the transactions we have in our mempool, we'll use the network message called I have transactions. Take a new network message card. You'll want one for each peer that you're connected to. Write on the network message the transaction IDs of every transaction in your mempool. Place the network message onto a network header or ring, then send the network message to your peer nodes. Once you receive an I have transaction card from the network, your node has some work to do. You need to figure out which of the listed transactions you don't know about yet and request them back from your peer. To do this, you'll take the network message card that says Send Transactions. Fill in the transaction IDs of the transactions you don't have yet and send this back to the peer that sent you the original I have transactions message. Now you wait for your peer to send you the transactions you're missing. If you get a Send Transactions card from your peer, you need to complete the request. Find the transactions that they are requesting and make a copy of them. Then you send the copy of this transaction to your peer using a network header or a ring to send it over the network. You'll need to be careful when making the copy so that you don't make any mistakes and accidentally send an invalid transaction. This is how transactions move across the network in a peer-to-peer fashion. Another word for sending transaction data this way is gossiping. Once you get a new transaction from the network, you'll need to use the transaction validation card to check that it's valid. All valid transactions get stamped as approved and then added to the mempool. As soon as a new transaction is added to your mempool, you'll need to notify all of your peers of the transactions that you have again. This process repeats until all the nodes have all of the transactions and there's no new send transaction messages being sent. Or you can end the mempool gossip stage after 10 to 15 minutes have gone by. Once enough time has passed, or the nodes have stopped sending each other messages, it's time to pause the game and find out who's got the most transactions in their mempool. The node with the most transactions in their mempool wins this round. Nice job on finishing the first competitive phase of the LARP game. Sometimes there are problems in this phase of the game. Here's some things to look out for. Connection drops. If a player at a node drops a connection, that's fine. They can re-establish the connections to other nodes after drops. Forgetting who sent you a message. Sometimes players forget which incoming node connection sent them a message. Computers have the same problem. One way that computers solve this is by noting on the message which connection it belongs to, so responses can be sent back to the same connection. Feel free to have nodes come up with their own solution to this problem. Nodes forget to make copies, but send the original transaction out of their mempool directly. This is a problem because they lose transaction data they already had. Have nodes request the transaction from a peer using the transaction ID to get it back. Nodes get transactions already stamped approved. Have them ignore the approved stamp and re-verify it. Nice try, peer. A node gets an invalid transaction. They can either fix the mistake, ask the sending peer to send the same transaction again, or drop the connection with the offending node. Transactions aren't making it all the way across the network. Remind nodes that they need to resend the IF transactions card every time a new transaction is added to their mempool.